this being recorded? There we go. It is being recorded. So I wanted to start out by giving you a little bit of a sense of why I'm interested in data science and what I love about Data 8, and then we'll get down to work. So one of the things I've been thinking about is what is data science, because as you know, nobody can really define it. There's no one agreed upon definition, whereas we all understand that biologists study life, living things. Economists study the use of resources, physicists study the physical world. I think data scientists, we study uncertainty. And if you think about it, almost every major decision you make in your life is based on incomplete information. There is uncertainty. And this is something we have to face. And it is a very important thing. And what I think we've discovered over the past 10, 15 years is just having a lot of data doesn't actually get rid of uncertainty. And so the more data you have, the more you realize that the world is very complex. And so whatever you can do to face uncertainty, deal with nuance, that is helpful. And so to the extent that we can define uncertainty, quantify it, measure it, it gives us an additional way of addressing it and making decisions. And that's what we're doing a lot of the time in data science. But decisions are about human beings and they're made by human beings. And so here, it really matters who is deciding what to decide. Who is deciding what data set is important to collect? Who is deciding what data set can be erased? What is important to study? And in data science, it's really important that we have the widest possible community of people engaged in it. Because otherwise, the subject loses. Not only does the human community lose, the subject loses. Because I think many of you will have heard, even though you are not deeply into data science as a discipline yet, that data science algorithms, people say there's algorithmic bias. Sometimes there is bias in the algorithms. Even if you don't know precisely what that means, could you post on the chat if you've heard this, something like this? Yeah, okay. So, human beings write the algorithms, and human beings, while we are informed by our experience is what is the reason we have our skills and what we bring, we're also limited by our experience. And so then everything that we do is limited by that. And so we need the biggest possible community of people engaged in data science so that our conclusions made by data science are not significantly wrong or off because of bias. So it is actually important for the subject to have a very different perspectives. And that's one of the things that I love about Data 8, because our student community is so different one from each other. Kelechi has a wonderful suggestion, Coded Bias on Netflix. Yes. And it is important when we come into Data 8, come into data science, to remember that you cannot do data science being brilliant by yourself in a cubicle. Data science requires communication, and requires communication with people who are very different from you. And that's a learned skill. So please, I hope you'll engage in that in Data 8. Don't talk only to people who are just like you, or only the people that you already know and hang out with, but try in your sections to meet other people who are quite different. And I would also ask that we're all mindful that the way we speak, the things we take for granted, the things we find funny, these are all informed by our experience, which can be quite different from somebody else's experience. So somebody, the things that we can take for granted, maybe can be out of a painful experience or positive, but maybe quite different from somebody else. Humor, and I have to discipline myself because you'll find over the semester that I wisecrack all the time. But I have to be very careful to remember that something that I find funny might not be funny to somebody else. So it's a good idea to just be mindful of these things, and we'll all make mistakes. But I hope in Data 8 we'll have a community that listens, where we listen to each other, with curiosity and with respect. And as a result, come out not only better at data science, but just, having more interesting perspectives. Certainly being part of the data science community has made me a better person. All right, end of sermon. I'll stop and take a couple of questions. Anybody? David, how do you want to do this? Yeah, Napoleon, the wisecracks will come at the least expected moments. I can't help myself. That's just how I do things. All right. So now we have a technical issue. I'd like to get down to some nitty-gritty, and I'm going to try and share my screen. So here's what's going to happen. We're going to spend a few minutes on just logistical nitty-gritty, and then I'll give an overview of what we're going to do today, and then we will jump in. What advice would I give if you don't have experience with Python? Just sit back and relax. And go into your sections, go to office hours, have our amazing staff and look over your screen, and it will sort itself out. But forgive yourself, you will make mistakes all the time, and that's fine. That's why we have error messages. That's why the notebooks will recover from mistakes. We set things up so that making mistakes is a normal part of things. Just don't worry about it and you'll be fine. But do take all of the help that's available. I should say, by the way, a lot of people ask about, what do I do if I have no experience with coding? And we say there's a lot of help available. I'll say that, you heard me talking about community bias, communication. All of this requires language. Yeah, so you'll be writing paragraphs. And that also is a learned skill, and we'll help you with that. It is a very important skill to learn how to say something that is technically correct, that is precise, but is in plain English. And it takes years to learn. Might as well start. What's your biggest piece of advice to succeed in this class? Have an open mind and try not to binge. Can you go to office hours if you don't have a specific question? Yes, but what I would suggest is, because we're worried about crowding these days, maybe we shouldn't all treat it as study hall. So hang out for a bit, but if it gets crowded, then just make your best judgment. Okay, I'm going to try something because I have to do this now, and because at some point it's going to come back to bite us if I cannot do this. So here we go. I'm going to try and share my screen. All right, David, could you let me know if you can see the Data 8 page?
You're good.
People can see the Data 8 page. I love it. Okay, so this page is your go-to page, and somewhere up at the top, which I cannot see because it's hidden by that bar, is a crucial page. This one, policies. This has every answer. Exams, labs, homeworks, due dates, it's all in here. And I discovered something really cool reading it myself. So please read that page because it has a lot of great information. In particular, all right, all, how are we with the slide? You see a slide? I think you do. In particular, It has nitty-gritty information. By now, you know that everybody has been assigned to a lab. If you haven't, please talk to your post on ed privately. Lab 1, you know, is done. Lab 2 will be released on Monday night. That's our regular schedule. Homework 1 comes out today sometime after lecture. I don't know exactly when. And it's due next Thursday night. So it's basically a sort of 1 week-ish turnaround. But if you turn it in the night before, then you can get 5 bonus points. I did not know about the 5 bonus points. I thought it was 1, but it's 5 bonus points. So hey, reading the policies page was a good idea. And office hours start next week, all afternoon in 145 Moffett, plus there will be more because we will have some online hours for the students who are remote. The instructors will announce their office hours. David and I were chatting last night about holding them outdoors. When I got outside my house this morning, the air didn't smell good. So, you know, if it's not one thing, it's another. But we'll figure it out. I'm very frequently available on ed and so on. So we'll be around. Let me pause for a second so that David can take some questions and I can look. David, should I look at the chat or the Q&A? Which would you rather I looked at?
I think we're good. I think I'm keeping up with most of the questions.
Wonderful. Thank you so much. I must say it's a little odd to just talk, but let me just pause for a few minutes for some logistical questions. David, when you think that it's time to move on, then I'll move on. How about that? Office hours starting next week, office hours every day. By the way, another class told me that 145 Moffett is freezing, bring a jacket. Okay, maybe I just get going. David, thank you for managing this huge chat. Okay, so what we're going to do today is discuss some of the concepts that are fundamental to data science, to statistics, indeed to making decisions under any circumstance. And because data science is not purely computational, we start out our first main lecture with no computation whatsoever. So today there will be no notebook, but starting from Monday, there will be both slides and notebooks, both of which will be available to you before the lecture. We're going to talk about, well, actually, let me just get started with an article on the web last July. And it has this wonderful headline: regularly eating chocolate is linked to a lower heart attack risk. It's from it's a report on a journal article from the European Journal of Preventive Cardiology, and it's a journalist report on that. And so it has this word linked in it, which is important to understand. It has this also a lovely picture of luscious chocolate. So link has a meaning, and I'll start out with a little bit of terminology. The article was about a bunch of studies, and the studies were on individuals, which the reason I'm giving you all these names in study subjects, participants, units, is because I use all of those interchangeably depending on the situation. In this case, it happens to be a whole lot of adults in the United States, Sweden, and Australia. It was actually a meta-analysis, which means that it was an analysis of several other analyses. And they were looking at the effect of what is called a treatment. And in this case, when you hear the word treatment, our mind naturally goes to a medical treatment, and that's not a bad motif to have. Keep that in your mind. In this case, it happened to be a particularly nice medical treatment, which was chocolate consumption. But a treatment can just be a feature of the individual. For example, if your individuals are cars, then the treatment might just be, is it a hybrid or is it not? It doesn't have to be something you do to the individual. And then you're interested in an outcome, right? Which is also sometimes called a response. So in this instance, we had this population of individuals, and we were looking at an outcome which was heart disease, cardiovascular disease, arterial disease, actually, and that had a precise definition. And the first question was, is there any relation between chocolate consumption and heart disease? And this any relation, which is normal English, the formal word for that is association. Association between two factors means any relation at all. And that is called a link. So you can see that this is rather a pretty broad definition. Independent and dependent variables asks somebody, yeah, that is definitely a technical term. The response is what in more technical classes is sometimes called the dependent variable. Okay, hold on. People who have read ahead, let me get to where I am. Okay, so is there a link? Yeah, sure. It's very reasonable to say there is a link because they established numerically that those who ate chocolate had a lower rate of heart disease. Now you see what happens when a paper like this comes out? This is cool because it's saying that people who ate chocolate had less heart disease, and so that means everybody wants to rush and go and eat chocolate. I do have something to ask. I do have something to ask about the chat. This is my personal request as a faculty member. And David might have a completely different approach, but in my lectures, what I would love for you to do in a chat is to imagine that you are sitting in a discussion section, and what you post in the chat is audible to everybody in the room. So in that setting, you would make some choices, right? You wouldn't talk over the person who's already talking. So for my part, I will make sure that I pause and I take questions. But when I see a stream of questions on the chat that are essentially talking beyond what is being discussed, it's actually really distracting to other students. So this is my fervent request. If I could please just have all of this stream when we break. There's no need to apologize. This is my first lecture with you, so this is just sort of my way of, trying to sort of put myself in a place where I'm actually teaching students. It helps me, so thank you for that. All right, so when there is a situation in which chocolate is involved, people get very excited. And people write articles, and they're all over the web. And in this case, they were really all over the web. And here are some headlines about that very same article. Chocolate is good for you. Is eating chocolate heart healthy? Study says yes. CNN, which I did not post here, said simply, bless you, science. Now, here's a question for you. Are these headlines essentially the same as that headline that said there's a link between chocolate and heart disease? They're not. They're not. They're overstating things, right? Because they're actually asking a different question. The question they're asking is, does chocolate consumption lead to, is it the reason for the reduction in heart disease? And that's a much more directed question. It is about this word causality that a lot of people are putting on the chat. Thank you. And this is usually much more difficult to answer. And in fact, there was one of the Market Watch, bless their hearts, had actually went and talked to somebody, and they were more skeptical. One of the things that Dr. Lichtenstein said was, you're asking people, what they were asking is, do you eat chocolate regularly? And the regularly was defined by at least once a week. And she's saying, well, okay, so the people who eat chocolate at least once a week have less heart disease. Maybe the people who don't eat chocolate once a week are not eating chocolate because they already have heart disease and their doctor told them to stop. So links are not the same as causality. For causality, you have to do a lot more work to establish that. Okay, let me pause for a second and take questions until we get to the, and then we'll get to the main example. Okay, so let me stop sharing for a second. I'll come back. We're going to talk today about a very important piece of data science to make a number of points, one of which is that data science isn't new. It's about making decisions based on incomplete information. It's about making decisions based on evidence that human beings have done since the beginning of time, or at least attempted to. And there is a fabulous, exemplary piece of data analysis that was done in the 1850s. How do we know for sure that two situations are correlated or positive? Hold that thought, we'll come back to it. Who is it? It's Kartikeya, hold that thought. Okay, is a strong link more likely to be a causality? Actually, no, later. Can I just say something? We're going to be talking about disease, and we're going to be actually talking about cholera in London in the 1850s. However, there are striking parallels to COVID in the world in 2020, 2021. I want to say something. Every now and then we're going to talk about COVID, but we are very mindful that this has been a difficult, heartbreaking thing for all of us, but especially to those among us who have had our loved ones go through this disease. Some of us have lost loved ones. Some of us have seen our communities hurt. So I will always say ahead of time that we're going to talk about COVID. I'm going to try not to make it a crucial part of what we're doing. If you are in a situation where this pains you, please send me directly an email, right? And I'll try to make sure that we at least minimize or give you a heads up about what we're doing and why. Does that seem like a plan? Wonderful, thank you. So here we go, one more time. No, wrong one. I'll get better at this, promise. Okay, so this is where we were. And so we're now going to look at association in a particular context, and we are going to go to London in the 1850s and take a look at that picture. That is an illustration from the satirical magazine Punch, which used to be one of my favorites. Take a look at that. Does that look to you like those are very rich people? It does not. Right, they're crowded. There's what appears to be a pile of something I don't want to think about up front. Not rich people. So London, parts of London in those days were, dirty, crowded. There was a lot of poverty. Dickens was writing at this time. Yes, exactly, Kartikeya, thank you. Cholera would come in and just decimate the population. And then it would go away. And some months later, it would come back and people would see it coming. There would be dispatches. I regret to say that it is, some diplomatic dispatch. I regret to say that it is now in Persia. Then it's in Germany. And once it's in Germany, people know it's only a matter of time. A ship will come to London and then it will be in London again, and then people will die. And that was frightening. And having thought about this example for so long, and I was really reminded of this in 2020 when we were saying, it's here now. It's in Italy, it's in LA. Any moment it's going to be in the Bay Area. It was exactly this. It was something that we did not know very well. We did not know how to cure it. Actually, it was much better known. COVID was much better known to the medical community, much better understood than cholera was at the time. Still, we didn't know how to deal with it. It was very, very similar. And we were frightened. We're still frightened. We're anxious. We're anxious for ourselves. We're anxious for the people we love. And so people try to think about causes. And in that period, the miasma was considered the leading cause of disease. And what is a miasma? It's a bad smell given off by waste and rotting matter. People knew this can't be a good thing. And so the people who thought of miasma as being the reason for disease are called miasmatists. The theory is called miasmatism. And it was believed to be the main source of disease. And its proponents, you recognize this person? Yes? Yeah, somewhere in your elementary school, maybe you went through and you heard that she was one of the early nursing pioneers. And there was another person, very important. The commissioner of the Board of Health at the time was a miasmatist. And everybody was, they didn't understand bacteria and so on, invisible creatures that would cause disease. This was not well understood. Right, so everybody was trying to find out why there is this disease, and there are some suggested remedies. So for cholera around 1850, fly to clean air, and that was actually Henry it was from a poem written apparently by Henry VIII. Henry VIII, ages ago. Okay, fire off barrels of gunpowder. This guy really liked the smell of gunpowder. So to get rid of a bad smell, what was his suggestion? Which is you take a barrel of gunpowder in the middle of London and you just let it off, and then the smell will be nice and then everybody will be fine. That was their suggestion. Somebody else's suggestion, this was actually Chadwick's suggestion, I believe. Maybe I'm maligning him, but I think that's correct. Which is to go to the top of the Eiffel Tower with a barrel that's very high, and there's clean air up there. You bring it down in a barrel and then you let it loose in London. Okay, so look at all the wows and the hers. Who's laughing? Is anybody laughing? All right, there's the lols. Yeah, okay. But how about we do a comparison? Last year, all us highly educated, scientific, all of these people, for COVID-19, disinfectant, all of these. Is exactly the same. Right? And why is it exactly the same? Because this is how human beings deal with anxiety. We try to find reasons. Okay, and it's not always rational. But it is the human condition. And we have to remember when we're doing data science that human beings are doing it. And now, who was it? I think it was Karthikeya a little while earlier who asked, how can we actually establish what is happening? Well, in the end, you need to do some science, right? And that's what this man did. No, not that Jon Snow. Okay, this Jon Snow. He was an anesthesiologist in London, and he was looking at what was going on with the cholera, and he did not believe the miasma theory. All right. One more time, a request. Please treat your commentary as things said out loud in a discussion section. Thank you. So Jon Snow did not believe the miasma theory. And why did he not believe the miasma theory? Because he looked at the data and he would see that in one house, everybody died of cholera, but in the next house, nobody died of cholera, right? Well, they're breathing the same air. So he was very skeptical. He thought it was something to do with what they were eating or drinking. And he did what has now become absolutely standard. He drew a map. That is his original map of the region of London which was being decimated by cholera in 1854. And so that's a street map. And he walked the streets, went house to house and counted, just asked how many people died. He also asked who died and so on and so forth. And let me give you let me explain a little bit in general what this map is like, and then we will zoom in. So he was suspicious of the water. And so this little thing here says pump. There's a water pump, the water pump in Broad Street. And there's one back here that is hidden under my chat, that is in Rupert Street. And these were the pumps that supplied water. People didn't have running water in their homes. They went to the pump to get water. He went to every house, and for every person who died in that house, he marked a little black rectangle. And if there was more than one, he piled up the rectangles. So this house had a lot of people die, unfortunately. Okay. And what he noticed was, here is the Broad Street pump. I'm sorry, it's small. The deaths all sort of circle around the Broad Street pump. He was very suspicious of the Broad Street pump. I'm going to zoom in. So Broad Street, here's the pump, and here are all the deaths. And he really thought that there was something going on with this pump. And he made sure that he examined what was going on in each household relative to that pump. One of the things he noticed was, so this house is close to the pump, lots of deaths. This place here, can you see? You can't see my cursor, can you? You can. Wonderful. Okay, so this place is the Lion Brewery. How many deaths in the Lion Brewery? I see 0. Do you see 0? Yeah. Why do you think no deaths in the Lion Brewery? What's your guess? What were they drinking? What they brewed. Yeah, but the thing is, yes, but also, if you're a brewery, you have your own water source. Okay, so they had their own water source, no deaths there. Workhouse is where they put a lot of poor people. When you couldn't pay your bills, the police, the bailiffs came and got you, and they stuck them in the workhouse where you had to go and do hard labor, basically. You would expect in those crowded conditions of poverty, lots of people would die, but there are a relatively small number of deaths in the workhouse. And the workhouse also had its own pump, right? So far it's all consistent. What he noticed was there were some deaths here where there was another pump. The Rupert Street pump is closer, but then it turned out that that pump was at the end of a dead end, and it was sort of inconvenient to get to. And so people didn't go there. There's a bunch of deaths that are relatively far away from the pump. Sadly, many of those were children because the pump was on their way to school and they would drink. Right? So everything corroborated what he thought, that this pump is the problem, water from the pump is the problem. There was one piece of evidence that he had to deal with, which was far away from Soho, far away from Broad Street, in Hampstead, which is a very leafy, genteel part of London. Even still, it is very expensive. Even now, there were 2 deaths due to cholera. And that he had to explain because, that was far away and that was evidence against him. And it turned out that those 2 deaths were those deaths of 2 ladies who used to live one of whom used to live near Broad Street. Her family owned a business near Broad Street. They were worried about the cholera. So out of love for their mother, they moved her to Hampstead. And her niece, I think some relative moved in with her. But you see, she didn't like the taste of the water in Hampstead. So again, out of love for their mother, they shipped to her every day water from the Broad Street pump. And at this point, John Snow said, okay, I got to do something about this. And he went to the municipal authorities and he showed them his data and he said, take the handle off that pump. And they took the handle off that pump. And that episode of cholera was waning, but it is believed that he reduced deaths in future episodes by doing that. Now, I'm going to show you something. This map, this map that you're looking at, there's Regent Street, there's Golden Square. I think you can see all of that. It's a part of London, right? And London, well, still exists. All of these places are still there. You got to hand it to the British. When they like somebody, they name a pub after them. Okay, so this is the John Snow pub, and you can see it's the same curve of Regent Street. And this is Golden Square, and this is Broad Street. There were so many Broad Streets that they gave this special one another syllable. And that is the John Snow pub. And in front of the pub, what is that? A pump, but what's it missing? Is missing the handle, right? This is the pump that is missing the handle. And you have all now been hearing a lot about the Centers for Disease Control. And the Centers for Disease Control, they have a saying. When they are trying to find a simple solution to a big problem, they will ask, where is the handle to this pump? This is now in the 2020s. This guy was in the 1850s. He is called the father of epidemiology, the study of epidemics. And he has really set out the parameters for how to do data science well. I'm a crazy devotee. And so I went there, and there's the pub. It has the picture of the pump, and there's a picture of the man that I recognize. But when you go into a London pub, it's crowded with people. You don't see a blank wall where you can see the photographs nicely. So there was actually a person sitting in front, and I was going to go in and ask them to move. And my family just started backing away. They're saying, okay, this crazy person, we're not related to her. But I walked up, and this very kind person and his group moved away so that I could take the picture. And I promised them that day that I was going to always show their picture when I taught my thousands of students. So this is Mr. Nicholas Cleary. Thank you very much for letting me have those pictures. Now, I've shown this picture a couple of times, and everybody knows now that I'm a crazy John Snow devotee, and they've themselves become devotees. And so just a month ago, I received an email from a former Data 8 staff member who said, Professor, I had to send you this. Okay, Weston and Alex, Data 8 staff, one of them is, I think, doing a PhD at Stanford, if I heard somebody else, one of the others at Google, they're long graduated. But they went to London, and where did they go? Other people go to the Tower of London or London Bridge. Our people go to the Broad Street pump. Anyway, okay, so this is all very well. But at this point, Snow understood very clearly that what he had was association. Drank from the Broad Street pump, got cholera at a higher rate. That's association. That's not clearly causation. Because if the people who drank from the Broad Street pump also, for example, bought their food from the same source, maybe it was the food and not the pump. He knew that very well. And so if you Google for John Snow's map, you'll get the map that we just saw, but that was actually not the map that helped him make the causal conclusion. John Snow had another map. And this was the map. What he did was he said, I will go and see where is the water coming from. And there were two water companies providing water to this part of London. One was for short called SNV, and the other one was called Lambeth. And you can see there's a green bit and a pink bit, and then a pink, a sort of sludgy colored bit, which says both. And that is what he was looking at. That's where his population was. And in that area, the water was provided by both companies. SNV, their water source, was downstream from where the sewage came out into the river, right? So their water was contaminated by the sewage. Lambeth, their water source was upstream. So their water did not contain whatever came out from the sewer system. And what he noticed, which is very, very important, was now that he had a comparison. He had a treatment group. Think of that. You can call SNV as the treatment group, the people getting the dirty water, and the other group is the control group getting water that's not dirty. And now you can compare one to the other. And the key is what he noted. There is no difference whatever in the houses or the people in any of the physical conditions. The key is that these two groups were very similar, completely similar, except for the water supply. So because of this, it was possible, if you see a difference in the outcomes of the two groups, to ascribe it to the water supply, because everything else is the same, all other things being equal. And so here is his table of data. This is the supply area, this is the SNV area, and this is the Lambeth area, and this is the rest of London. And you have the number of houses in the area, the number of cholera deaths, and the deaths per 100,000 people. Now, if I look at SNV, and if I look at the first line, suddenly it had about 1,200 cholera deaths, which is much greater than the 98 cholera deaths that were from Lambeth, but that is not the significant evidence, because of the SNV served more houses than Lambeth. And that is why you have to look at the rate, the number of deaths relative to the size. And there, the rate of deaths from SNV was about 10 times the rate for Lambeth. And here now, you have kind of a, you really have some evidence that it's what's being provided by SNV that is doing the job, but there are multiple questions who being asked about, so do you have to eliminate everything else? Yes, yes, and it's hard to do. It is hard to eliminate everything else. Yeah, you know, I think, Shivodia, you're right. It should be computed relative to the number of people, because houses can have more or less people. I think technically you are right, but this was a good start. Okay, so what should you do? You need your two groups to be as similar as possible apart from the treatment. So you should, and if you don't, then you have to worry about what is called confounding. Okay, confounding is a factor that messes up your conclusions. And so you get into trouble when you have systematic differences between your two groups that are not the treatment. And in such a case, you can't make a causal conclusion, though you can see association. And if you're just observing something, for example, if you're observing, the example in the textbook is women in their pregnancy, the effects of, say, alcohol drinking during pregnancy on the baby's birth weight. You're just observing what you're observing, and potentially the women who elect not to drink during their pregnancy are also making other choices that affect their baby's birth weight. So you can't actually tease things out. And so you just have to be aware that you will, if you're making decisions based on just observation of the data that are in front of you, then there is likely to be some confounding. If you are able to account for all of these confounding variables and control for them, yes, then you can establish confounding, and that utopia can be achieved how? Well, it can be achieved by randomizing. Somebody already suggested that. And randomizing has a way of creating two groups that are similar to start with. And then Joseph, what counts as a systematic difference? How large does the systematic difference have to be? This is why this is a 15-week course and not a 1-lecture course. This is what we're going to be talking about. But what randomization does, you randomize carefully following the rules of probability, then you can actually measure those things. You can account mathematically for variability in the assignment and also for how large a difference might be just by chance. And so randomizing is the key, and what you will be running is called a randomized controlled experiment. You have your subjects assigned to treatment and control at random. This is sometimes also called a randomized controlled trial, RCT. And that is the gold standard, right? It has been for a long time in medicine, but now also in economics. The 2019 Nobel Prize was won by 2 friends of mine from MIT. And their huge contribution was to bring randomized controlled trials into prominence in economics. Okay, I want to talk about the word random. Because if you go to a dictionary definition, one of the first synonyms is haphazard. So let me actually, Noah has a really good question. When the water assignment is predetermined by a company, do we still consider them randomized? This is what is called a natural experiment, because the way the water was assigned really seemed to have no relation to who the people were in the houses at all. So it actually wasn't a proper randomization. He had a natural experiment, and in the end, somebody had to identify the cholera bacterium to nail down that this is the cause. That was a very good question. Okay, one of the first synonyms that comes out in the dictionary is random is haphazard, but random is not haphazard. Random is anything but. Randomization has to be done very carefully. Now I have 1 minute. Can I tell you a story? Please? Okay, so a long time ago in the psychology department in Berkeley, there were some experiments being done on mice. Right? And the mice were being selected for this experiment. And one of the things that we had to do, what the experiment had to do, is to make sure that the experiment was replicable. And so therefore, they kept track of the characteristics of the mice. And for some reason, the mice in their experiment were always heavier, just always heavier. On average, they were heavier. And they thought they were picking at random. And so graduate students would go pick out some mouse, and but then their sampled mice were heavier. And now here, the thing is, there was a very biased approach to this experiment because people did not think from the point of view of the mouse. You're a mouse. You're in this box or cage or wherever it is, running around, minding your own business. And this huge, humongo hand comes down from the top. What do? You're a mouse. There's a hand coming. You run away, right? And who gets away? all the smaller ones, right? It is difficult to catch them. And so if you eliminate systematically the low end of the weight distribution, then your average is going to be higher. The lab workers thought they were selecting at random. They didn't care which mouse. They stuck their hand and put one out, but it was not at random. So when they went and assigned, labels to all the mice and then picked the labels and then the mice, then the average weight worked out, right? It was what it was supposed to be. Okay, we're at 11:01. I'm actually going to stop now because I think we do have to give up this. David, am I right? I think we have to give up this Zoom. So what I'm going to do is I'm going to head out. I'm in Evans Hall on the 4th floor. I'm going to head out and I'm going to go somewhere into Memorial Glade and I'm sure you'll find me.